Hello everyone, this is Mrs. Gaikwad from AISSMS Institute of Information Technology. Today we are going to see the topic of Dijkstra algorithm. Now what Dijkstra algorithm actually is? This algorithm is used to find the shortest path in a given graph from a given source node to every other node in the graph. It also actually can be used to find the shortest path to a specific destination node. So here we can terminate the algorithm once the shortest path to the destination node is known. Now there are four steps to Dijkstra algorithm. Step one is set the distance of source vertex to 0 and all other as infinity. This is basic step at the start. Next step will be relax all the vertices which are adjacent to the current vertex. I'll explain this step in detail with example. And step 3 is choose the closest vertex as current vertex. Step 4 is we are going to repeat step 2 and 3 until we reach the destination. So we'll see an example for this. Consider the given graph. Here, suppose the graph is having A, B, C, D, E, F, G. These many number of nodes. And on the edges, there is a distance given to reach from suppose A to C, A to B, likewise. So on the edge, it will be a distance. In the node, it will be the name of that node. Now suppose we want to reach from node A, we consider it as a starting vertex, and we want to reach node E here. Now we want to find what? The shortest path to reach from A to E. So at the start, we'll start from node A. So as per step 1, the distance of node A will be what? It will be 0 and all other we consider initially as infinity. And in the second step, what we'll write is, we'll write whatever be the adjacent nodes are there. Like for this node A, we are having adjacent nodes C, B and G. Adjacent means that which are connected to that specific node. So the distance of DC, that means distance, this A to C distance is 22. DG, it is 8. DB, it is 16. So these values we write. So stepwise when we consider, now we can start like, suppose we start with node A. Now what I've done is, we have written here all the distances A, B, C, D, E, F, G. So at the start, we know distance of A is 0, and from the adjacent nodes, DG is the minimum distance because we know three nodes that are connected to A are 22, 16 and 8. So 8 will be the minimum distance. Now when I want to calculate the minimum distance to reach to suppose B, so dB, whatever be the connected are there. So this is the formula where it is the minimum distance of dB. That means there is a direct edge, and which are other connected nodes. Like here, suppose DG, we can reach B from A to G and G to B. So it will be DG plus weight of GB. That means distance to reach from A to G and distance from G to B. So minimum distance dB, we already know a direct path is 16. So 16 comma dG, which is 8, and weight of GB, which is 10. So with that formula, it comes out to be 16. And DF, we can reach from here also. That means G to F, F to B. At that time, it is DG, which is 8, and G to F, it is 8, which is 16. But DF is what? F is not directly connected to A. So it is initially we have made all as infinity. So it is infinity. So minimum will be 16. So A to F again will be 8 plus 8, that is 16. That means we have calculated the next node in the graph. So DB is 16, DF is 16. Now next is DB, we have calculated minimum distance is 16. So you need to mark. DG, we have already finalized it as 8. So these two are already relaxed. A and G, we have finished that. Now we have reached what here? DB. Now for B, whichever are connected. So for B, the adjacent nodes are C and D. Why we are not considering G? Because it is already the minimum distance we have taken from the start node. So we'll start with this. So what remains? C and D. So distance of C will be minimum of DC because it is directly connected to node A, which is 22, comma DB plus weight of BC. So it is 16 plus 20. So minimum comes out to be this one, 22. Likewise for DD, that means this distance. Now D is not directly connected to source node A, so it is infinity. So DB, which is this one, 16 plus 4. So it comes out to be A to D we can reach with minimum distance as 20. So we'll mark that again. And DE, B, the C, D we have finished. Now E, F are still there. So likewise, distance of E will be what? 28. How it is? D to B, as E is again not directly connected to A, it is infinity, comma, distance of B, which is 16, and B to E, which is 12. So it comes out to be 28. DF, F again is not, we have already have DF, which is 16. Again, alternate path, if you want to check, it is 16 plus 6, which is 22. So minimum of these two is 16. Now we have reached minimum of DF. The next node is 16. So consider that again adjacent nodes of it as E. So it is 28 because minimum of DE, which is 28, and DF plus F2E. DF we have calculated 16 and F2 is 14. So minimum of 28 and 38 is 28. Likewise, go on relaxing all the edges. We have relaxed A, B, G, F. Now D will come into picture as from the remaining, whichever is minimum, we are going to relax that. So it is 20. So DD, again check the adjacent node of D, it is C and E. So 22, 24 likewise. So 22, change D as 24. Now again minimum is DC, then DE. So the distance of vertex A to vertex E is 24. So again you can see I have marked the relaxed edges, and DE, it comes out to be the minimum now. So it is 24. So we have calculated with the help of Dijkstra algorithm the shortest path from node A to node E. Thank you.